to do the scientific method. The first step is an observation. So you're seeing something in the world and you're going, like I wonder why that's happening. Then you have a question. So why is this happening? How is this happening? Trying to figure out what your observation is. Your next is your hypothesis. This is the answer to your question that you think is going to be correct. I think that this is going to happen because this, and it is just an educated guess. You may have no idea what it is, but it's some sort of starting point, right? And then you have an experiment. Well, you have a question to what you've observed, and now you have an educated guess. Let's test it out. And with our experiment, we then collect data. When you collect data, you don't collect data just once, right? You don't just go like, cool, I did one experiment, I'm done. Science would not work that way. So you collect data over and over and over again over a long period of time to make sure that what your hypothesis is in your experiment, that you've tested it all out. And then you take all of the data you've collected and analyze it, and you come to a conclusion. Is your hypothesis right? Yes or no, and why? And after that, you may have to retest, re-experiment, recollect data, and go back and back until you get it correct. But this is the overall scientific method.
So today we're talking about the scientific method, and we're specifically using a parachute model to talk about it. So you've already seen Miss Lincoln fall out of the sky doing her skydiving. That was our observation, right? You physically saw her doing something. And then we decided, right, we came up with our question. Our question being, right, how does string length affect the flight time of our parachute? So we see here, right, all of our different ways that a parachute falls. So we get gravity pulling us down, and then we have wind resistance opening it back up. So today we're going to be shortening our string length, and we're going to be lengthening our string length, and we're going to keep just a basic stock one. So we're going to be making 3 parachutes today to see how each string length will affect how much air we'll be able to capture, the parachute will be able to capture, and thus how well our parachute will be able to work.
All right, so as Mr. Diaz said, our observation was me skydiving. Woo! Our question is, so how does the string length affect the flight time of the parachute? Could have just asked a question of like, how do parachutes work? You could ask anything, but you have to make it measurable, something you can actually do an experiment on. We can experiment on this. All right, something called the independent variable is the thing that you change. So in our question, what is the thing we're changing? We're changing the string length. And so our dependent variable is the thing that we measure. What are we measuring? We're measuring the effect of flight time. So does the flight time increase, decrease? And these 2 variables are what go into our hypothesis. A hypothesis, you probably remember, is something of an if blank, then blank, because. Most students forget the because. The because is really important. This is our scientific reasoning behind it, not just because I think so, which isn't a real reason. It's a good one, but not scientific. So in our hypothesis, if we blank the string length, so our string length is our independent variable. So if we increase, decrease, I'm gonna say, I think that if we increase, oh, that's a lovely arrow. If we increase the string length on our parachute, right? So if we take this length and we make it larger, then the flight time, which was our dependent variable of our parachute, will go up, go down. So I personally think that if we take the string length and we make it bigger, I think that the flight time will go up. Okay, better arrow. Go up because it will open up more and be able to catch more air. This is my scientific reasoning behind this. So we have our independent variable and our dependent variable in our hypothesis, and this is how we create this, like a template. Going back, a few things we need to keep in mind. We need a constant. A constant is things that stay the same. We don't want to change the materials. If I make a parachute out of napkins and Mr. Diaz makes a parachute out of coffee filters, how are you going to compare that? They're not the same. So we need the same materials, same location. If I drop it off of the top of Mount Everest and Mr. Diaz drops it in the desert, isn't there going to be different weather, wind, temperatures? It's going to completely affect it. Who drops it? If I drop one and Mr. Diaz drops one, then that's a problem, because what if I'm really forceful with my drop and he's really light and dainty with his drop? And how you drop the parachute. All of these things need to stay the same so that you can have results that can be tested each time. So we just want to test one thing, because if we test all of these, you can't compare them. Also, we want to control. So one original parachute that never changes to compare to all of other parachutes. So we want one that never changes and things that start constantly are changing.
Currently we are in the 1000 building. We came here because it has a really nice ledge for us to drop our parachutes and to test them. The last clip you saw was the time lapse of us actually creating our parachute, which is part of the third step of the scientific method, which is the experimentation part. And then the next part, which we're also in, is also the experimentation part, where we're actually testing. We're going to be dropping them and trying to collect some data, which would be the fourth step in the scientific method. I want you to remember that we keep things very constant. So we have our parachutes down here that we created. You saw that we have all three of them. They're all three identical. They have the same resources, okay? Same napkin, same sticky dots, same string, same amount of paper clips. The only thing that was different, right, was the length of the string, right? It's very important so we know when we drop them and we're collecting that data for flight time, that the only thing that's making it different is the string length.
2, 1. Look at that. Oh yeah. 2, 1.
Oh, look at it go.
Hello everyone, I'm Mr. Holtz, for those of you that don't remember who I am. So we just got all of our data, we put it into our nice pretty looking table here, and then we transferred this table onto the whiteboard. So right now we're going to take a look at all 3 different drops that we did for each of the 3 different parachutes, and we're going to look at how to figure out what the average time was for each of the drops for each of the parachutes. Once we figure out what the average was, we'll take them over here, and then we can graph them to compare what does it actually look like graphically. So let's refresh ourselves on what does it actually look like to find an average for multiple values. So generally, the super basic way to think of it is to take all the values from that one set. So this would be our set of trials for the short parachute. We're going to add up all of the total times, and then because we did 3 separate trials, we're going to divide our total time of adding all 3 of these by 3 to figure out what the average was between them all. So how do we do that? Our first trial was 6.45 seconds. Our second trial was 6.05 seconds. And our third trial was 6.22 seconds. So if we add all of those, we'll get one value on the top. Since we're doing this for 3 trials, to find the average, we need to divide by 3. And once you do that math, you get 6.24 seconds. So this would be our average flight time for the short parachute, 6.24. And we've already calculated the other 2, which are 6.91 seconds and 7.94. All right, awesome. So we've got all of our trials, averaged them all out, and now we're going to take a look at these averages and plot them on this bar graph over here.
So the last step of the scientific method is actually analyzing our data and coming to a conclusion. So Mr. Holtz so nicely found our averages, and we're going to put those averages onto our bar graph. Okay, it's going to be a bar graph. So the first one we have is 6.24 seconds. So we have our string length, our independent variable always goes on the x-axis, and our dependent variable, which is a measurable thing, measurable things are usually in numbers, goes on the y-axis. Numbers go up and down. Okay, so our first one, 6.24, so I'm going to make a nice bar graph over my S, going to go all the way up to about what 6.24 would be, just above I6, and I'm going to come back down. There's my bar graph. Then my next one, my control, my 6.91. I'm going to go all the way up to 6.91 here. I see that's just below the 7, so I need to go a little farther. And then there's that one. And then finally my last one, 7.94. So I see my 7's here, 8. I'm going to go almost all the way up to 8. A little less. Graphs are a really nice representation of our data because we can physically see the difference rather than just looking at the numbers. So we can honestly see, right, when we thought about our hypothesis, we first hypothesized that as the string length increases, our flight time increases. And we can actually now see that, right? As our string length increases from short to the control, which was our middle, and to the long one, right? Our long one had the most flight time. Our control, which was the middle one, had the second most flight time, and then our shortest one had the least amount of flight time. So our hypothesis was supported. If it wasn't supported, what we would do is we would go back to the drawing board, we'd come up with a new hypothesis, come up with a new experiment, and then test it again and again. And then that is exactly how you do the scientific method.
Again, I'm Miss Lincoln.
I'm Mr. Holtz.
I'm Mr. Diaz.
And thank you for watching.
If you like this video, hit that like, subscribe button, comment down below. What do you use the scientific method for? Tell us what experiments you'd like to do next. We'll see you on the channel.
Mine was awkward.